All right, today we're going to go ahead and get into section 4.3, be focusing on the Pythagorean theorem. All right, so here we go. Let's go ahead and get started. Let's talk about the special parts of a right triangle. All right, the side across from the 90 degrees is going to be the most important side. We call that the hypotenuse. All right, it's very, very important that we can identify the hypotenuse each time in order to set up our Pythagorean theorem once we learn the formula. The other two sides are just legs. So we have a leg, and then we have the hypotenuse. All right, we're about to learn a formula for it, but just note that the hypotenuse is always going to be the letter C, and the legs are going to be A and B. Now we can switch A and B, but it's important that we get C every time. The hypotenuse, that must be in the correct spot. Now notice the hypotenuse is also the longest side. All right, it's the longest. The way we remember it is it's across from the 90 degrees. All right, if you can label the C correct, the rest is just plugging it in the formula and then solving it. All right, so here we go. Let's go ahead and talk. The Pythagorean theorem is one of the most famous formulas in the world. All right, it's the sum of the squares of the lengths of the legs equal to the square of the hypotenuse. All right, so here's our big formula coming. The way we always think of the Pythagorean theorem is a squared plus b squared equals c squared. Remember, A and B are legs. C always has to be the hypotenuse. If you can plug it in correctly, the rest is just cleaning it up and solving it algebraically. All right, here we go. Let's do some problems with the Pythagorean theorem. All right, find the value of x, give your answer. We're not going to go simple radical form. We are going to go with decimal unless it's a perfect square, and then we're going to have to go ahead and solve it. You'll notice right here that first I'm going to label my side C. It's across from the 90. It's the hypotenuse, which means my other two sides are A and B. Doesn't matter, as long as I have C correct. Now, when I plug it into the formula, A squared, so 6 squared, all right, plus B squared, so 8 squared, equals C squared. All right, this time X is on the right-hand side, so I'm going to clean this up. 6 squared is 36. 6 times 6. 8 squared is 64. 8 times 8. That should equal x squared. I notice on the left side I can combine like terms, so 36 plus 64 gives me 100, and that's equal to x squared. Now remember, the opposite of squared is to square root it, so if I square root that, it'll cancel the square. I'm left with the square root of 100 equals x. And notice, we know the square root of 100, so we need to clean this up. Square root of 100 tells me that x will equal 10. All right, so as long as you identify C correctly, we can plug everything into the formula. All right, let's go ahead and try number 2. I'm first going to go ahead and label my C. It's across from the 90 degrees. It means my other two sides are A and B. Again, it doesn't matter which one we make A, which one we make B, as long as we have C correct. Let's plug it into the formula. 4 squared plus 9 squared equals x squared. Well, 4 times 4 is 16. 9 times 9 is 81. And that should be equal to x squared. Now, let's combine like terms. 16 plus 81 will give us 97 equals x squared. Now, to solve this, I'm going to go ahead and square root to get rid of that square. So my answer I can leave as square root of 97 because it's not a perfect square. So you may leave your answer like that since I can't take that any further. If you put that into a calculator and you have one available that you can use, then technically it's 9.8. We will take either answer for this. So if you left it as 9.8 or square root of 97, you are all good. All right, now, those were two problems where x was on the hypotenuse, so x was our C. Let's look at how to solve some problems where x lands on a leg. All right, so again, stay in the habit. label your side C, and then call your other ones A and B. Doesn't matter, but as long as you get C correct, you're headed in the right direction. A squared plus B squared equals C squared. So we plug it right into the formula. Now we go through and we clean it up. X squared is X squared plus 144 equals 15 squared will give us 225. If I subtract 144, let's change colors, 144 from both sides, you'll notice we're left with x squared equals 81. Well, I can't leave it as x squared. I need to get x by itself, so I'm going to square root both sides. Ooh, that's a perfect square, so I can take the square root of 81, which tells us x equals 9. All right, let's do another one that won't turn out so pretty. All right, if I mark my triangle, remember across from 90 is C. My other two sides are A and B. Again, A and B can be switched. Let's go ahead and set it up. X squared plus 2 squared equals 8 squared. All right, let's go ahead and turn these into numbers. X squared plus 4 equals 64. All right, I'm going to go ahead and solve this. I'm going to subtract 4 to get it over, and you'll notice I'm left with x squared equals 60. Now, if I go back and I square root this on both sides to get rid of that, you'll notice I'm left with the square root of 60, so I can leave my answer like that because that's not a perfect square. Or I can go ahead and put the square root of 60 on my calculator, and you'll notice it gives you 7.7. Either one of those answers would be all good with us. So it's up to you on whatever works the best for you. All right, let's keep going. Here we go. We're going to look at some more challenging problems now. So we'll look at 5, 6, and 7. We're going to continue to do the same thing, but we're going to need some space to do some work here, so we'll squeeze it in. Here we go. All right, number 5 is our challenge problem. Just because we have some goofy numbers in the picture, same pattern. Label your sides C, A, and B. All right, let's go ahead and plug it in. So 6 squared plus 2 root 3 squared equals x squared. Now, here's the problem, is that second term. So 6 squared is 36. All right, now, the hard part is what does this next part turn into? So I'm going to do some side work. You can put this right into a calculator if you put it in exactly the way it looks, the way I put it here. Otherwise, think of this. 2 root 3 squared means that I'm doing 2 squared times root 3 squared. 2 squared is 4. Root 3 squared just cancels the square root, so that turns into 4 times 3. So this number technically turns out to 12. So if you don't have a calculator, you're squaring both terms inside. And that should be equal to x squared. Now, when I clean it up, 36 plus 12 is 48 equals x squared. Remember, to get rid of the square, we square root both sides, so I'm left with square root of 48, which I could leave as my answer. If not, I can put that into my calculator, and I get 6.9. So really, the challenge is to make sure you can do this piece right here correct. If you have a calculator, put it in with parentheses and then square it. It'll give you the answer. If not, do the side work like I did down below. Distribute the power to both of them and then clean it up. Remember, the square and the square root cancel, so we're just left with the 3. All right, I'm going to draw a little box around that problem so that you know the info for that is all there. Here we go. Let's look at another challenging problem. All right, we're going to go ahead and find x. I'm going to label this A, B, and C. I'm going to start to plug it in, so 5 squared, well, let's erase that. Let's do it right here. 5 squared plus x minus 1 squared equals x squared. Now, again, this just requires some work. 5 squared is 25. The problem is that we have this right here in parentheses that needs to be squared. All right, we're going to take a walk back to algebra land. If I have something in parentheses squared like that, it technically means that I need to write it twice and do FOIL. X times x equals x squared. X times negative 1 is negative 1x. Slide over. Negative 1 times x is negative 1x. And negative 1 times negative 1 turns into positive 1. All right, now when I write that in here, I'm just going to combine my middle terms here, and I'm going to call this x squared minus 2x plus 1. And that should be equal to x squared. Now, don't give up here. Don't get frustrated because there's a lot of stuff in this. It's actually going to clean up and solve nicely after we combine like terms. You'll notice I have an x squared. You'll notice I have a negative 2x. You'll notice I had a 25 and a 1, so if I add those together to combine like terms, I get 26. And that should be equal to x squared. Now, here we go. Let's solve. You'll notice if I subtract x squared on both sides, I'm left with negative 2x plus 26, and technically x squared minus x squared will turn into 0. Nothing's left. Continue to solve. If I subtract 26 over to get my x by itself, I'm left with negative 2x equals negative 26. Go back and divide both sides by negative 2, and we get x to equal 13. Okay, so anytime we have to do the FOIL, our x squareds are always going to cancel, and then it'll turn into solving for x. All right, let's look at one more of those that can get nasty, but another way that we can set it up and solve it. So let's label our side C. I'll label it A and B, and we're going to go ahead and plug it in. A squared plus B squared equals the expression of x plus 4, which was C, squared. All right, now we can clean up this side real quick. 12 squared is 144 plus x squared. It's this right side that I got to do some work over on the side for. So I'm going to do some side work. Remember, if we have something in parentheses like that squared, we're going to write it twice, and we're going to use FOIL. X times x is x squared. X times 4 is 4x. Slide over. 4 times x is 4x. 4 times 4 is 16. Remember, if I clean that up, I can combine like terms, and it turns into x squared plus 8x plus 16. So that's going to go on the right-hand side of my equation. Now again, we said this looks ugly with all the x's and x squareds, but remember, it's always going to clean up nice when we solve it. I'm going to subtract x squared from both sides. It turns to 0 and cancels, but I still have things left. So 144 equals 8x plus 16. All right, let's go ahead and subtract 16 over. I'm left with 128 equals x squared. Remember, we free up our x squared, we square root it, so I can leave my answer as square root of 128. Oops, sorry, Let me go back. I don't know where I took my x squared from. I'm left with, whoa, my bad. I'm left with 8x left. Now to solve it then, I'm just going to go ahead and divide by 8. Again, my bad on that. I was left with an 8x. So x turns out to be 16. All right, those are considered the 3 most challenging problems I could give you with Pythagorean theorem. Otherwise, they're like the ones we did above. All right, the last thing we look at is called the converse of the Pythagorean theorem. So they're going to give us 3 numbers, and we plug it in to test if it is true. If a squared plus b squared equals c squared, then yes, it's a right triangle. If it does not equal it, then no, it is not a right triangle. The main thing with this is that when they give us 3 numbers, c will always be the biggest number. So if they just give us 3 numbers and ask us, are these the sides of a Pythagorean triple, then what we check of a right triangle is we check to see if it's true or false. If we plug it in the formula and it's true, the answer is yes. If we plug it in the formula and it's not equal, then it's false. C is always the biggest number they give us. A and B will be the other 2 numbers. All right, so let's go ahead and check. You'll notice they give us 5, 8, and 3. I'm going to highlight C. C always has to be the biggest number. That means A and B could be the other 2. So I'm going to do 5 squared plus 3 squared equals 8 squared. If this is true, then yes, it could be a right triangle. If this is false, then no, it cannot be a right triangle. Well, I know 5 squared is 25. I know 3 squared is 9. And I know 8 squared is 64. Well, 25 plus 9 tells me 34, and that should have been equal to 64. Well, that is not true, right? 34 is not equal to 64, so our answer is no, this cannot be the sides of a right triangle. They are not equal. All right, let's go ahead and go to letter B. Again, I'm going to highlight the highest number or the biggest number, and I know that's C. My other 2 sides have to be A and B. So 4 squared plus 3 squared should be equal to 5 squared. Well, let's clean this up and check if it's true. 4 squared is 16, 3 squared is 9, 5 squared is 25. Well, 16 plus 9 is 25, and that's equal to the 25, so this one worked, it's true. So yes, this could be a Pythagorean triple, which would be a right triangle. All right, let's continue to C and D and check. Again, I'm going to highlight my biggest number so that I know that's my C. I'm going to take my A and B and plug them in, so 9 squared plus 11 squared should be equal to 15 squared. All right, let's clean up our numbers. 9 squared is 81, 11 squared is 121, and 15 squared is 225. If I combine like terms on the left side, I get 202 should be equal to 225, and that is not true. Those are not equal. So my answer is no, this one did not work. It cannot be a right triangle. All right, let's go ahead and do one more. I'm going to highlight my biggest number. That's my C. Means my other 2 sides are A and B, so 9 squared plus 40 squared equals 41 squared. All right, let's clean these up, turn them to numbers. That's 81 plus 1,600 which should be equal to 41 squared will give you 1,681. 1,681. Go ahead, combine like terms on the left. I get 1,681 equals 1,681. That's true. So yes, this could be a Pythagorean triple. So again, a squared plus b squared equals c squared. The main thing is to make sure you have your c correct. C is always the longest side or the biggest number, and c is always across from the 90-degree angle when we solve it. All right, we'll now do some practice with this and make sure we're all good with Pythagorean theorem.